converted mass into weight, then what is difference between mass and weight? Are you know about difference mass and weight? Mass is constant all over the universe. Mass is constant all over the universe. Mass into gravitational force is equal to weight. Weight is different on different places because gravitational force is different in a different regions, different planets, different stars. Therefore, weights are different. Mass into gravitational force is equal to weight. It is suppose the weight of your body on your place, that means in our earth, is different on different planets like moon and other planets, because the mass of earth as well as moon and other planets are different. Therefore, their gravitational force is also different. If gravitational force is different, therefore weight of each object having different masses are different. Therefore, weights are different. If we go on the moon, we cannot walk as we walk on the earth. How? Because the mass of moon is 1/6 times less than that of our earth. Therefore, weight of any body or our body is less in on the moon. Therefore, we cannot walk as we walking on the earth. We can jump from one place to another place while walking on the moon because less gravitational force. Satellite, of course, are balanced with solar system. In a solar system, there are different stars as well as planets, but they are fixed stable on their places because of different then one more picture is given on your in your book, page number 1. Concept of the gravitational force and the gravitational force between the earth and the moon. Page number 1, science part 1, gravitation. There is a picture is in your page number 1. Moon and earth. Moon is rotating just earth because of the gravitational force of Earth. And one girl just sitting under and an apple which is dropped down towards Earth and not toward moon. Can you tell me what is the reason behind it? Apple doesn't go upward, it comes towards the Earth because that apple just attracted towards Earth because Earth having comparatively more gravitational force than that of moon. Therefore, apple does not go in upward and come towards Earth. Because of this gravitational force, Newton found some laws. Newton's first law, Newton's second law, Newton's third law. Yes. Then there is also one more scientist who also found some laws. Homework for you. You should write all these three laws and learn these three laws because these Newton's three laws are the best for this chapter. And you have already studied in previous year, 9th standard, Newton's law. Then circular motion and centripetal force. What is centripetal force and circular motion? If you tie any object to the thread and just rotate it in a circular direction, then the force which are attracted by that body in a tangential position, that means at 90 degree. That is the circular. Then Kepler's first law. The orbit of a planet is an ellipse with the sun at one of the foci. Then what is Kepler's first law? The orbit of a planet is an ellipse. Have you listened the word ellipse? What is the difference between circle and ellipse? Circle having a center which is equidistant from the points which are on the circumference of a circle. That means any point which lie on the circumference, they are on equidistance from the center. They are all the locus of the points, loci of the points, set of the points which are equidistance, means equal distance from the center. That is the center of a circle. But Such a one center cannot possible in case of ellipse. Ellipse is like eggs. Have you seen egg? अंड पाहिले ना तुम्ही? अंडाला जसं असं लंब वर्तुळाकार असतं त्या आकारामध्ये इलिप्स असतं. And the orbit of planet is also like a ellipse. Orbit means the path of satellite. The orbit of planet is an ellipse with sun at one focus. Now see what on your page number 3, one picture 1.4, the orbit of a planet moving around the sun. You know, all the sun, all the planets, all the stars, which are continuously moving in a fixed path, that is called orbit. And such a orbit is having one foci, F-O-C-I. In your book, the picture is given and a fixed point, sun, is mentioned. Then the path on elliptical path of the planet is shown 1, 2, 3, A, B, C, D, and E, F. They are from their foci, from the sun. They shows one of the foci. All these distances are shows one of the foci. This elliptical orbit of a planet revolving around the sun. The position of the sun, which is indicated in your book, in your picture, as a point. Yes, or sun, and AB, CD, and DE are the elliptical path of the planet. This is Kepler's first law. Then what is about Kepler's second law? The line joining the planet and the sun. Line joining the planet. Planet means any Earth, Mars, whatever it means. There are different planets, and the line joining from the planet and the sun sweeps equal area in equal interval of time. That means time required for the orbit, the path, elliptical path is equal. It is line joining the planet and the sun sweeps equal area in equal interval of time. Each equal interval means equal part of time covers equal distance. Then AB, see what the picture in your page number 3, AB, CD are the distances covered by the planet in equal time. That means after in equal interval of time. Equal interval means equal part of time. The position of the planet starting from A to C are shown by B and D respectively. B and D. The straight line AS, straight line CS sweep equal area in equal interval of time. Area A yes B and area C yes D are equal. Now see what? Yes. Okay. Have you seen? This is the Kepler's second law. Then just next Kepler's law, like Newton's law, there are also Kepler shows three laws. Then Kepler's third law is the square of its period. What is meant by period? Period means equal interval of time of revolution around the sun is directly proportional to the cube of the mean distance of a planet from the sun. The square of the period. Period means time interval. It is suppose capital T is the period of revolution and small r is the average distance of the planet from the sun. R is the average distance and T is the period of revolution. Then we can write in the mathematical form T square is directly proportional to R cube. Capital T for period. Period means equal time of interval and R is the average distance of the planet to the sun. That is, T square is directly proportional to R cube. That means we can write it in the mathematical form T square upon R cube is equal to constant. It is supposed to be K with a constant. Then we can write T square upon R cube is equal to K. K is the constant of proportionality or the constant, that is K. And you can take like the constant of Kepler's third law. Therefore, T square upon R cube is equal to K. Kepler obtained these laws simply from the study of the position of the planets obtained by the regular observations. He had no explanation as to why planets obey this law. Kepler indicated the mathematical statements of the Kepler's law, but he doesn't explain why planets obey these laws. Obey means to follow these laws. There are three Kepler's law. Just we have discussed about the Kepler's three laws. Then we will see how these laws helped Newton in the formation of theory of gravitation. We know the Newton's law of gravitations, first law, second law, third law, and this Kepler, how they are related. Kepler's three laws, how they are related to the Newton's three law. We'll see now. Newton's universal law of gravitation. What is universal law of gravitation? Newton's universal law. Just today, we know about only Newton's three law, but this is one more law about Newton's universal law. This is also related to the gravitation. Every object in the universe attracts every other objects. At the initial, we have discussed about the gravitation. Any two objects, they are attracted to each other. Same thing is observed in Newton's universal law of gravitation. Whatever the mass of that object, even that mass are the gravitational force. You doesn't matter. You doesn't bother about the whatever the mass of the object. It may be very less, tiny, small, even though they having the gravitational force. Therefore, in Newton's universal law indicates every object in the universe attracts every other object with a definite force. Some forces we cannot come to consideration. How you and your friend sat on the same bench, but you doesn't know the gravitational force between you and your friend because they are not attracted. They does not come to know about the attraction between two girls. तुम्ही दोन विद्यार्थिनी एकाच बेंचवर बसलेले असतात पण ह्या दोन्ही मुली एकमेकांना आकर्षित करतात असं वाटतं का नाही because the gravitational force between you and your friend is comparatively very less. Therefore, we does not come to know about the gravitational force between you and your friend. But this Newton's universal law indicates any two objects are attracts to each other with a definite force. This force is directly proportional to the product of masses. Product of masses means suppose m1 be the mass of Nainika and m2 is the mass of Tirtha and both are sat on the same bench, on one bench. They are attracted with a definite force, but they do not come to know to Tirtha or Nainika. It doesn't matter about their force of attraction, force of gravitation, but Newton's universal law says they have a specific gravitational force, specific definite force. Force is directly proportional to the product of the mass of the two objects and inversely proportional to the square of the distance between them. M1, M2 means M1 into M2. Mass of both girls, Tirtha and Nainika, they are multiplied. M1 and M2 is directly proportional to the square of the distance and with the distance or d with the distance between two objects, then we can say that the Newton's universal law of gravitational or force between them is F, capital F is directly proportional to M1, M2 means M1 into M2 and inversely proportional to the d square. Therefore, we can write F is directly proportional to M1, M2 upon d square. D is the distance between two objects. We can write G is the constant of proportionality. G, capital G, is the constant of proportionality. M1, M2 upon T square. F is equal to G, M1, M2 upon D square, where G is called the constant of proportionality, and that G is also called universal gravitational constant. G is called universal gravitational constant. G is called universal gravitational constant or constant of proportionality. The unit of G is Newton meter square plus upon kilogram square. The unit of gravitational force, universal gravitational constant, is Newton meter square per kilogram square. M be the distance between two objects having the mass M1 and M2. N is the force. Therefore, Newton meter square per kilogram square. The value of G is equal to 6.673 into 10 raised to minus 11 Newton meter square per kilogram square. Newton meter square per kilogram square. This is the G, universal gravitational constant. Now, uniform circular motion and magnitude of centripetal force. Have you understood about this Newton's universal law of gravitation? You can keep in your mind this formula. Some examples can come at the time of your examination. Yeah, is equal to M1 M2 upon D square. We'll see the examples which are related depends upon this formula. Next, uniform circular motion or magnitude of centripetal force. The force is always depends upon their speed. The object is constantly acted upon a force. The object is constantly acted upon by a force directed towards the center of the circle. Suppose you are having one object and you have tied it with a string and you move in circular motion. What happens at that time? That object is constantly acted upon by a force directed towards the center of the force. If we release that thread from our hand, what happens? That objects move just very rapidly away from you or away from your center of that circular path. That is in tangential form. This force is called the centripetal force. जर आपण एखादा लोखंडी बॉल किंवा एखादा दगड एखाद्या दोऱ्याला बांधला आणि तो बांधलेला तुम्ही हाताने असा गोलाकार फिरवला तर त्याचा फोर्स हाताजवळ म्हणजे सेंटर जवळ तो अप्लाय करत असतो. m is the mass of the object, v is the speed, and r is the radius of the circle. Then we can write this force F is equal to mv square upon r. Here a planet is revolving around the sun in a circular orbit in uniform circular motion. Planet, it is supposed to be a light or any metallic ball, and sun is your hand. When you are moving, you are rotating in a circular motion just around your hand. Therefore, we can compare that metallic ball as a planet and your hand is as a sun. And planet is revolving around the sun in a circular orbit, that is uniform circular motion. The speed of the planet can be expressed in terms of the period of revolution t. Here one more time, capital T is here for period of time. The speed of the planet can be expressed in terms of the period. Period means equal interval of time. The distance traveled by the planet in one revolution is equal to perimeter of the orbit. What is mean by perimeter of the orbit? Perimeter of the orbit means circumference of the orbit. How we can find the circumference of the circle? By which formula we can find circumference? Circumference is equal to 2 pi r. Good. 2 pi r. Sinde, sister?
Yes, sir.
Have you understood about this?
Yes, sir.
We got. Okay. Then 2 pi r is the circumference, path of circumference. The distance traveled by the planet in one revolution is equal to perimeter of the orbit. Perimeter of the orbit means circumference of that circle. Perimeter means sum of all sides. In circle, there is no side. There is a circumference. Therefore, that is the total length of the circumference. It means perimeter of the orbit. And we know how to find, how to calculate the circumference of the circle. That is 2 pi r, where r is the distance of the planet from the sun. R is the distance of the planet from the sun. Therefore, time taken is equal to period of revolution. Period of revolution means
Time
equal
taken.
time taken by planets when orbiting just around the sun, that is capital T. V is equal to distance traveled, V upon velocity, speed, that is distance traveled upon time taken. That means 2 pi r upon t. Please understand. V for speed of the object. V is the speed of object. Therefore, V is equal to distance traveled divided by time taken. Therefore, how much distance is traveled by the planet just around the sun? That is one circumference. Perimeter of the distance, that is 2 pi r. That is the distance traveled in one rotation and time t, capital T. Just we have seen about F is equal to mv square upon r, and here we can put the value of v, that is 2 pi r upon t. V square means bracket square upon r. Therefore, we can write it 2 square 4. Then m is as it is. Pi also having bracket square, therefore that is pi square and r square. And here r t square, r square cancel. Therefore, we can write 4 m pi square r upon t square is a period. Then multiplying and dividing by r square, we get, that is f is equal to 4 m pi square upon r square into r cube upon t square. If we multiplied and divided here by r square, then we get r square is r into r square, it becomes r cube. Therefore, we can cut it according to the Kepler's law. Just we have seen k is equal to t square upon r cube. That is Kepler's law. Therefore, we can write here F is equal to 4 m pi square upon r square k. But we know that 4 m pi square upon k, all this is a constant. This is a constant. Therefore, we can write f is directly proportional to r square. F is directly proportional, sorry, inversely proportional to r square, or f is directly proportional to 1 upon r square. Then the gravitational force is much weaker. We cannot come to know about the gravitational force, which is much weaker, even though we can compare it with Earth and any object which is on the Earth. We consider the force, but gravitational force is comparatively very weak force than other forces in nature, but it controls the universe. All this our solar system is totally depends upon gravitational force. Even though gravitational force is too weaker, this is possible because of the huge masses of the planets, stars, and other constituents of the universe. This solar system, this weaker gravitational force control all our solar system. We come to know what important of our gravitational force. Okay, we got all these guns.
Yes, sir.
Any doubt for you?
No, sir.
Hello, hello. Excuse me, all girls, please. In this Srishti,
No, sir.
Yes,
have
sir.
doubt? Tirtha, Srishti,
No, sir.
do you got
No, sir.
it?
Yes,
You got
sir.
it?
Yes, sir.
Okay. Then you have Anika. Anika. Yes. Then there are some problems. There are some examples which are related on Newton's law of gravitation. Then